Hello everybody. So you have joined the Hager webinar. My name is Stephanie Field and I am the marketing manager at Rexel. We're just going to give a couple of minutes just to wait for a few more attendees to join us. Just maybe one more minute just to see if we have a few more to join us, and then we can kick off. Okie dokie. Brilliant. So please note that this is a recorded webinar. It will be available to watch on demand on the Rexel website. This webinar is also CPD accredited, and the certificates will be sent directly to the email address that you have registered with for the webinar, and it can take up to 4 to 5 weeks to arrive. If you have any questions throughout the session, please feel free to pop them into the Q&A bubble, which you can select from the menu on the side, and we will answer them at the very end. Today, I'm delighted to be joined by Paul Chaffers and Paul Collins, both technical training managers at Hager. So I'm now going to hand over to Paul and Paul from Hager to take you through the webinar.
Thanks, Stephanie. Yeah, so good Friday afternoon to everyone. So I'm Paul Collins and so my colleague Paul Chaffers. And as Stephanie said, we both are responsible for the technical training and technical content really of sort of customer published data that we produced. Now, as you can see on that slide, hopefully then, we both sit on various different panels. So we're both member of BEMA, which is the Manufacturers Association Wiring Regulations Technical Committee. That's just feeding input into like the JPEL for future editions from a manufacturer perspective, of course, to the wiring regulations. I sit on one of the JPEL panels, Committee A, which just deals with verification and other aspects. And as you can see there, Paul sits on the electrical vehicle technical group as well. And then Paul's got a lot of history with JPEL as well. So previous to joining us, Paul was sitting on one of the JPEL B panel, which dealt with thermal effects, which has a lot of relations to what we're talking about today, AFDDs. So let's go straight into the topic, and we'll talk about then have a good focus on what AFDDs do, how they work, etc., and where they get used. So AFDD, first of all, now they were in the 18th edition, of course, as a recommendation. Now that caused a lot of not confusion as such, but a lot of comments to the JPEL committee when we went to Amendment 2. Now that's when we decided we need more emphasis on AFDD. So at that time we put some definitions into part 2 of the wiring regulations and give it actually a definition. It wasn't there then before that time. And AFDDs can exist in various forms. The British standard for AFDDs allows 3 essentially different forms of AFDDs to exist. It could be a single device. So an AFDD, that's all it is in its own little package, if you like. And then it will need other, obviously, protection devices that go along with that device. Now, most manufacturers have gone for indent 2 there. As you see, like anyone, well, probably most people now have a lot of experience of seeing, feeling, touching AFDD products. And you'll notice now they're a single device integrated with the other protective devices, which we need, of course, mostly RCBOs. So most of the products for AFDDs are RCBO AFDD. But we and other manufacturers also have MCB AFDD, just in case you didn't need RCD protection or you had it elsewhere maybe. And others, indent free there, they did start being that way by some manufacturers, but I think they've kind of gone away now. But there's a separate unit, so you kind of had to clip it to some other protected device. So it was almost like a piggyback device, if you like. So, you know, there's the definition there. Most manufacturers seem to have settled with indent 2. Now, what are they for? Of course, there is a fire protection product. So the goal of Artful Protection is to increase the protection we have against fire. Now, UK fire statistics tells us we still have somewhere around about 20,000 electrical fires in the UK, not all caused by, you know, the wiring as such. There's misuse, there's product problems as well, of course, but that's a high number of electrical fires. So, you know, AFDDs have been brought in to actually try to do something about that. Now, Other products we have could obviously help with fires. You know, MCBs, RCDs, surge protection devices can, under certain conditions, provide protection against fire. But what none of them can do is protect against series or parallel arc faults. Maybe except with the RCD for parallel arc fault, but none of them can actually protect against a series arc fault. The series arc fault, what is it? Hopefully you might see kind of in the little picture in the middle at the bottom now. It's a kind of a break in a cable, it's a poor join, it's a badly repaired join, and there's a little arc jumping a tiny little gap in the cable. And that little arc is heat, and that heat, of course, inside a cable, inside the insulation of a cable, is potentially an electrical fire. So the series arc is in line, if you like, and a parallel arc is from one conductor at one voltage to another conductor at another voltage. Now, if those conductors were lined to earth, yes, an RCD might pick that up. If those conductors were lined to neutral, again, no other product we have in existence before AFDDs can help with that kind of issue. So, you know, what we have with the triangle there, if you like, we're trying to give it like a top off, you know, with the, you know, top off the electrical protection that we have for the UK, really. Now, I'm going to hand over to Paul for this bit because he was very instrumental with the introduction and where we are with this. So, Paul, let you know, perhaps you can give an explanation of how we got to this regulation in Amendment 2.
Okay, thanks, Paul. Yeah, good afternoon, everybody. Yeah, so as Paul said, prior to Amendment 2, it was a recommendation that we used AFDDs, okay? Now, during that period of time on the build up to what was the draft for public comment for Amendment 2, the committee was also looking at the international committee drafts. Now, how it works is the UK has to follow the technical intent of the international IEC documents, okay? We do have sometimes slight differences and UK only regulations, but generally we have to accept the technical intent of those international documents. Okay, so before it become a harmonised document, the committee draft was looking at AFDDs more or less in all locations, because in other countries they've been using them for many years, and there might be different reasons. There might be timber framed buildings or whatever. They may be justified, but in the UK, it didn't feel appropriate to just adopt these AFDDs onto all circuits and all installation types. So what the committee really focused on was certain aspects. So let's look at the regulation. 42117 states that arc fault detection devices conforming to 62606 shall be provided for single phase AC final circuits supplying socket outlets with a rated current not exceeding 32 amps. Okay, so just breaking that down, we're looking at socket outlets, okay, because the socket outlet is the one thing that you've got no control over what the user does with that socket outlet. We can design our wiring systems to be very robust with correct cable radiuses. We can look at periodic inspections to look for loose terminals, but what we can't do is control what equipment gets plugged into the socket. So these AFDDs have sort of gone further than our traditional protected devices, just looking after our fixed wiring. We're now considering what is being plugged in, okay? So that's the socket outlet aspect of the regulation. And the 4 locations are built around risk and, you know, really being able to justify whether or not an AFDD was right or not. So first of all, obviously, when the discussions for this regulation were happening, it was after the very tragic Grenfell Tower, and everybody was aware of how difficult some of these high-rise buildings could be with evacuation and the danger. So anything there that could possibly increase the fire safety and provide additional fire protection was seen as a positive. So any buildings above 18 meters in height or above 6 stories, which were being classed as high-risk residential buildings within that regulation, required AFDD for the socket outlet circuits. We then looked at houses of multiple occupancy. A lot of these types of houses are not designed in day one to be a HMO. They're big old houses that have been split up over the years to create different sort of dwellings within them, and they're not always done to the best standard. And on top of that, we often get a mixture of families that are in there that may not use the shared facilities such as the kitchen. They may take equipment into their own sort of living quarters, into their bedrooms. They may have heaters, they may have cooking equipment running off of extension leads. Again, the purpose of the installation was not designed for such loads, so HMOs made the list of premises that would require this additional fire protection. Then we looked at purpose-built student accommodation, just purely because you know, students, quite often they're young, they leave the family home, they go out, they will use a manner of electrical and electronic equipment. They might not always use the proprietary charging leads that comes with such equipment. So purpose-built student accommodation made the cut. And then lastly, care homes. And this came off of the back of a very tragic care home fire. I think it was in the early 2000s in Scotland. And it resulted in the fatalities of 14 residents, okay? And the fire investigation found that electrical arcing at the distribution board location was the root cause of the fire. Now, there was a lot of things that went wrong with the building and the different compartments and the way that the staff dealt with it. All these things added up to the fatal loss that we saw there. But essentially, the root cause was arcing. So care homes, they also have that difficulty of evacuation. They've got elderly tenants that are, you know, maybe awkward to move or very slow to react. They might also have some that are not quite in their right minds, that might be trying to plug things in that they shouldn't be, or whatever. So for whatever reason, this is where the direction of the regulation has come from. So you'll notice the regulation is a shall regulation. So that means you must provide AFDDs for socket outlet circuits in those locations. And then because they were recommended previously in the 18th edition, it remains a recommendation for single phase AC final circuit supply and socket outlets in all other premises. So that's kind of where it all comes from and stems from. Now, for the first time ever, I think it's on page 18 in the regs book, we have some guidance on the language that's used within the regs. Quite often over the years, I've heard people arguing about certain regulations, and when you look at the regulation, it might not even be a requirement. It might just be guidance, or it might be a note that's just informative. So the language has now got some guidance on there, and we can see here that the recommendation is something that we should do, is the verbal form of that implication. So, you know, it's not a sort of, oh, it's only a recommendation, we shouldn't bother with it. We should really be looking at this. Now, of course, if you look at the definition above the table there could be several possibilities of reaching the same level of safety, and a designer may decide that an AFDD is not required in a certain application because of the types of wiring system, because of sprinklers that are present, or whatever. So it does give a little bit of flexibility, but we shouldn't be just ignoring it as a recommendation. The verbal form used in this table in the regs is something we should be doing. And such recommendations may extend to things like this thatched cottage that we're looking at here. Whilst the reg focuses very much on socket outlets, as manufacturers, we do provide AFDDs and other current ratings. And we could see that a thatched cottage where we may be looking at the possibility of vermin that might be in the loft, it might be a good idea to any circuits that are passing through that loft space to have additional fire protection by an AFDD. So I've just mentioned vermin and rodents. That can be a problem, and where arcs can originate from. We can also have that from thermal overload. We can have it from cable insulation that has had UV problems, where we've had damage or age or incorrect radiuses. We also have, we've spoken a lot about socket outlets. We have trapped and crushed cables. We have damaged insulation. And as Paul's spoken about, sometimes the circuit may be on an RCD, and that may be able to pick up some of these faults, but not always. We can have loose termination. So there's the whole manner of faults that may be able to be protected by these devices. And this little sort of curly whirly join here explains it quite well, and I'm gonna hand back to Paul because he likes to talk about this.
Yeah, thank you, Paul. Yeah, so yeah, but because of the cable types that I mostly use for in our installations, and especially flexes, really, once you start getting arcing, you get some carbonisation, which allows a little current path, of course. Now, that current path is an electrical arc, which increases carbonisation, which can increase the current path. The current path increases the arc, which increases the carbon, which increases the current path. And you can see what's happening here, hopefully. Once you start getting a small arc, because you start getting this carbonisation, quite often it will increase. And it'll only go one way until it gets to such a point that heat is built up to such an intent, obviously, that this cable type is now reached the ignition temperature. So it's now reached so hot, it now catches fire, and the cable starts catching fire. Of course, then whatever else is around the cable, if there's anything else flammable nearby, that catches fire, and then obviously a fire's well underway. So we'd like to, with AFDDs, of course, nip this in the bud before we got to this point. So once we started getting electric arc, if we could nip it there, then obviously we won't be on this ever decreasing circle or ever heat rising circle that we could potentially be on. That's the point of that little curly whirly thing there. So how does AFDD actually work then? Okay, well, they are actually quite pretty much a microprocessor based. They're analyzing what the voltage and current going through the product looks like. Now, in digital form at the top, and obviously in like a CAD drawing of our particular product at the bottom there. Now, the bottom part of that product you'll see on the bottom right end of your screen there is essentially an RCBO. Now, where the AFDD takes over, we just put this bit on the top, if you like. So what would have been previously the RCBO terminals, hopefully you now can maybe see as the current is now forced through this other core, this secondary measurement core for the product. Now, this clever little core is not interested in the value of the current coming through it. It's not interested in any kind of balance. That's the other part of the product's job to deal with. What this core is actually looking at, what does this current and voltage specifically look like coming through the product? And then it's obviously connected to some kind of microprocessor for decision making, which makes the the relationship between what does this look like? Is it of such a shape that it causes an arc? And then obviously we get the trip signal. So you can see from left to right, we go through the product there. So the AC goes through the product, which is analog. To make the decisions, obviously the microprocessor has to see it in digital form, and then there's all sorts of algorithms which it compares to, because obviously we get lots of arcs naturally occurring in all sorts of equipment we have these days. So the AFDDs actually knows lots of equipment and say, well, this is a naturally occurring arc from a drill or washing machine or whatever the product may be. So it obviously has been programmed to ignore those and only pick up on what is abnormal arcing conditions. And if it sees them, of course, it will send a trip command and then actually trip the main contacts of the product. There's no secondary contacts in the actual AFDD. It just sends the command obviously to the MCB part of the product as such. And what it's really focusing in more is actually how it kind of does focus really in do its job, if you like. With the AC waveform, of course, it crosses zero every now and again, so every 10 milliseconds actually. So when it crosses zero, there's no voltage, there's no arc. Now, when the voltage climbs either positive or negative, then the voltage becomes like a level of voltage could become kind of a trigger point that starts that arc. So it looks at several 0-point crossings. It doesn't make one decision of one 0-point crossing. These things fortunately do have a little bit of time to work with and actually assess a few 0-point crossings. And if it sees the same phenomenon after several 0-point crossings, the voltage rises to, 50, 60 or whatever the volts is, and then you see some other current and frequencies flow through. That's when it sees this is likely to be what's called a dangerous electrical arc, and it makes that decision. So when I say they can work pretty slowly and take time. I mean, I'm talking in a microprocessor world, really. They still work really fast, actually. You know, they still will work within something like at least a second. So they're very, very fast in our world, but obviously in the microprocessor world, they do have a certain amount of time to make that decision. Because what we want to do is obviously make the correct decision. We don't want these things to be causing all sorts of tripping problems when there's naturally occurring arcs. You know, the device there, if that was the case, would be unusable, unworkable. So we do want the product to only obviously do its triggering when it does actually see an issue.
Okay, thanks, Paul. So we've got a video to play here. Unfortunately, we can't use the sound on this call, so I'm going to try and explain it along the way. But basically, this is in one of our labs. It's what you can see up on the top here is a cable specimen that's been prepared with a series arc on it in accordance with the product standard. Okay, so it's a cable specimen test. I'm going to play the video and then I'm going to pause it, Paul, and we're going to try and explain what the different devices are doing.
So let's get to the devices and then we'll talk through what they are. So at the bottom there, you can see what looks like 3 devices. Now, these 2 are the protected devices. Now, and the one on the right is actually just a switch, so we can switch the current on. So if we can stop at the, well, if we can just, so we can stop there just for 1 second. So what do we see here? So in the center of the picture on the right-hand side of those 2 products, a single module product, is the AFDD, ARR932U. That's an RCBO stroke AFDD. Now, on the left-hand side, I know it's not a UK standard product being 2 module, but the left-hand product is just an RCBO. So it's a 16 amp B curve, as you can see there, 30 milliamp RCBO. Now, as we roll on with this video, you're going to see when we can have the circuit controlled by AFDD in one instance and the circuit controlled by RCBO in the second instance. And that's the point of the switch as we roll through. So let's roll the video a little bit longer, Paul.
And just this last switch on the right here, this is the switch which introduces the current to the arc fault. Okay, so this introduces the fault. You'll see the operative trying the AFDD, and you'll see it react very quickly with no flame, and then he moves on to the RCBO and has to manually disconnect that because the cable would catch fire. Okay, so the AFDD is shown doing what its job is. Obviously, the RCBO is not designed to detect arcs. You also see our colleague try to re-energize the AFDD onto the fault, okay, and it won't have any of it. It just keeps disconnecting because the fault is still there. So I'll play the video now, Paul. I think we've explained it, and hopefully you'll be able to see what's happening. Disconnects very quickly, doesn't it, Paul?
Yeah, and then you'll see actually him trying to switch that back on as well, as Paul said. And what's going to happen with a close-up view? You see a little bit of a spark, of course, that is the arc, but then it's very quickly extinguished. But then when we see the RCBO, then we'll see something considerably different. That's him trying to switch it back on, actually. That shows the quick little flashes there. And as Paul said, you know, it immediately detects that problem and switches off. So what happens now?
It quite clearly shows the benefits of the AFDD, doesn't it, Paul? You know, where it disconnects, detects the arc, disconnects with the RCBO. It was quite clear that the problem was going to carry on until a fire could occur. So
and it is really a good visual representation of what really happens, isn't it? in real life.
Yeah. Which is why we've introduced a video to the slide pack to try and give the customers an understanding of, what lengths we go to as manufacturers to make sure that these products really do meet the product standard. Okay, Paul, we have a few myths, don't we, in the industry? And
So first of all, we still get the odd question actually. So socket outlets, we chose socket outlets in the UK, but our socket outlets are still primarily wired in a kind of a ring circuit fashion. So, we still get the odd question about, well, they don't work on ring final circuits. Now, regardless of what Paul said earlier, it's not particularly there for the fixed wiring, it's for the kind of the plug and the flex that comes away from the socket outlet. If we analyze what individual point is on the socket outlet, we can see whether it will work or not. So first of all, we can get two conditions. If you remember, we get series arcs and parallel arcs. Now, if you get a series arc, remember what a series arc is. It's a kind of small little kind of break or join or something like that, or high resistance point. Okay, and so a series arc doesn't happen on a ring final circuit purely because there's two ways of getting to the same point, isn't there, on a ring? So you've probably more got like an overcurrent condition than a series arc condition on a ring final circuit. So that's what people are focusing on. Series arcs, yes, do not appear on ring final circuits. Absolutely, agree with that statement. However, parallel arcs on the actual fixed wiring are possible. And if the AFDD did see a issue between a line and a neutral conductor, now I'm not saying line and earth as well, of course, but socket outlets are likely to be RCD protected, which will also see that. But a line and a neutral conductor, an RCD won't do anything about. Now, if that was on the fixed wiring, the AFDD would see that and it would disconnect. But really, as we get from the plug, the flex, the appliance, even inside the appliance to a certain point, that could be series or parallel arc at that point, and the AFDD will see those just as well. So, for that point coming off the ring circuit, the AFDD is really there to do the job.
okay, thanks, Paul. So one of the things that always happens when a new product comes out is installers, inspectors, testers, they want to know, what's the impact on our everyday lives? Is this going to be more time consuming to test? What do we have to watch out for? So the obvious thing that springs to mind is insulation resistance, and we know that the regulations want initial verification carried out at 500 volts. Okay, and the reason for that is that cables are drawn in, they're pulled in, they may be damaged, and only 500 volts can really pressurize that cable to test that it's okay. So that's done at initial verification. And then once we connect our accessories, we can then follow up with a 250 volt test just to prove that the connections are good and nothing's been pinched when we've screwed sockets back, etc. Okay, so what do we have to be aware of with AFDDs? Well, you need to check with the individual manufacturers that you're using, but with the Hager ones, we've built in a certain amount of resilience with these devices. Okay, so if you look at the image there, you can test straight across the terminals there with the conductors connected to it with a 500 volt test, providing that you meet these two conditions. You must have the switch in the off position, and you must not press the blue test button. Now, Paul's going to explain a little bit about the diagnostics in a bit, so that'll make a bit more sense with the blue test button. But providing you don't press it and you've got the device in the off position, you can do your 500 volt test quite safely. The other test would be the ZS test. Okay, so earth loop impedance test, earth fault loop impedance test. Now, as Paul said earlier, most of these devices, customers are choosing to purchase an RCBO/AFDD, but it is possible that you can purchase an MCB/AFDD, okay, but most of them are using an RCBO, so we would say use the low current test setting on, which most modern meters have these days anyway, to avoid any sort of unwanted operation and to allow you to obtain your ZS test value. So with regards to the testing, these devices test themselves. So the product standard states that they must test themselves every day. The Hager devices test themselves every hour. And if they do find an internal failure, they will trip off and they will show that, as Paul's going to explain in a little bit, they will indicate that they've had an internal failure. Okay, so there's nothing for the installer to do to test these. There's no test machines out there. You don't have to take it out and put it into a test bed like the one that you've just seen at the Hager lab. There's nothing to do, but from a functional testing point of view, when you first install them, if there is a test button, then you should press it to ensure that it trips. Not all devices may not have a test button, ours does, and make sure that it does its job. And if it's an RCBO, you're going to be doing that anyway. So lastly, we would just look at what are the requirements for the model forms. Not much really. They've added a column for the manual test button of an AFDD. And if you're pressing it for an RCD anyway, it's just an extra tick in the box. And there's an extra tick there just to show that it's been satisfactory and you've operated the button on a minor work certificate. So really nothing much to it. Now these have been out, we've sold a great number of these devices already, and we're starting to get feedback from our customers. This customer made a statement online that the AFDD, Hager AFDD, saved us from a fire. And when they investigated, they said it was a door mechanism had mounted on a washing machine. Okay, now we followed up and got this confirmed in writing that the indicator showed it was a series arc. Okay, so the device didn't go out on any other setting. It went out on that AFDD setting. It went out for a series arc. Okay, so we're getting some good positive stories about how these do provide additional fire protection. And because we've talked about the indicator there, I think it's time now for me to hand over to Paul to talk you through what these indicators actually do.
Yeah, so let's have a look at the indicators. So all manufacturers have some kind of fault diagnostic codes for the product, if you like. Unfortunately, it's not in the standard for the product, so it will differ between different manufacturers. So, what the information from Hager, of course, is not the same as the information from anyone else. But generally, they tell you the last reason for the device trip. Now, especially if it's an RCBO AFDD, now there's a number of reasons why it could have tripped. You could have seen an overcurrent. It could have seen a residual current. It could have seen an arc. In this case, it could have seen an arc. What type of arc? So it's very handy to have several kind of colors or indicators somehow on the product that tells you why it tripped. Now, this is the reason why you can't press the little test button while you're doing an IR test, because with ours in the off position, what we do is actually power the product. So when in the off position, okay, so we can press the little blue test button and you'll see the little LED indicator window light up. Now, some manufacturers, you have to turn it back on to actually get the fault diagnostics. Now, clearly, if there's a fault there, as you saw in the test video, if you turn it back on, of course, you can't turn it back on because there is a fault there. So, and you won't be seeing that, of course, when you're trying to turn it back on. It'll be somewhere else around the installation. So we didn't feel it was appropriate to have the diagnostics in the on position. We wanted the diagnostics in the off position, the similar diagnostics in the off position. So if it's tripped, press the blue button and it will tell you in some way why it's tripped. As you can see there is more or less 8 statuses. Okay, if you want to ignore the first 2, the on or off status, that's fine. Okay, so apart from that, it will tell you if it's flashing red and yellow, that there's actually seen a series arc fault. If it's flashing red, it's seen a parallel arc fault. So not only do we tell you it's seen an arc fault, we tell you what type of arc fault has happened. So it just gives you an indication of where to start looking. If it's seen if it was just solid red, it's a residual current fault. So you've got to do that kind of fault diagnostics, the same as if it was an RCBO, if you like. If it was flashing red and green, you can see it's some kind of overload. So we're looking for a short circuit somewhere. If it was flashing yellow, this is the hourly test the product does. So every hour, the product's doing the test. If you remember from what Paul said a minute ago, if it flashes yellow, it's done a self-test and it's now no longer able to do its job of arc fault detection. Now, of course, we don't expect that to happen many times, but of course it is a feature of the product. So if it does an internal test and fails, you would need to know about it. Otherwise, you're going to go around looking in the installation for some issues and they're not there. It's the product itself. One other thing there is over voltage. Okay, it's not an over voltage protection device. It's not a surge protection device as such. Okay, but it will if we have a sustained over voltage, something like about 270 volts, or for a while, a second or so, you know, it will trip out as well. So that gives the equipment extra protection. So it's not a replacement for surge protection device. That just that little yellow indicator which I wanted to put in there. So all the manufacturers tell you the last reason for it trip, which is useful. Okay, last reason for it trip, but you know, some extra information is also useful for the on the product. So what we've done with our product, we've integrated some kind of Bluetooth mechanism inside, so we can actually connect to it and talk to it and find out some information from it. So there's a little app you can download called Hager Pilot. Okay, we use it for a couple of things. We use it for the protection part of the Hager Pilot. You do have to register. It's free, but you do have to register with us. So we just make sure that, you know, people who are able to use it are using it, or people shouldn't be tampering with it who aren't. Not that any harm can be done by accessing the app, but we'd rather only people know what they're doing or accessing the app, of course. And you get some information about the color coding again, the fault codes. You know, there is a sticker we provide for the consumer, but obviously that will be quite small these days. So the app will give you more indications of what the fault coding is meaning. There is a little bit of guidance what to do with various fault codes, but more than that really is the slide on the right there, or the picture on the screen on the right there, the event history. This will give you the last 16 reasons that the device was tripped. So if there was an issue in the installation, you know, say it was a series arc issue, okay, we would see series arc, series arc, series arc, series arc, all the way down that list, or parallel arc, or whatever the issue was, we would see all the way down that list. Now you see the screenshot we've got there. It's a bit of a mixture because we use it on a test rig, which we simulate different operations. So you know, the event history really does give anyone being called to a site when an AFDD is tripping, why is this device tripping? And it's really the start point to help installers, anyone doing any fault finding, where to go. If it's our product, make sure you have the app, connect to it, and find out why it's tripping, find out the reasons it's tripping. Now, also, because of the way they work, so the microprocessor in the algorithm, I don't know if you remember, like I said a little while ago, it knows machines today have an ARC signature. It knows what the signature of washing machines, of a drill, of whatever, lawnmower, whatever else it is. It knows what that ARC is, and that's kind of programmed into the product. So these things we expect to be around for a number of years. So the average life of an installation is what, 25 years, I guess. So there is a reasonable chance that something in the future is going to come on the market which isn't known today by this product. You know, if we think the electrical equipment we had in our lives 20 years ago is completely different to electrical equipment we've got in our lives today. So there is a possibility of the device not understanding this new ARC and tripping. Now, okay, that is potentially a problem, and it's a potential problem that if that happens, that the device will have to be replaced. But what we've done is thought about that and tried to future-proof the product. So because we can talk to it, we can update it. So if we know there's a new product that's entered the marketplace, someone's invented something new, okay, we can update the system, update the firmware inside the product. So when you do connect to it, you'll see on the left-hand screen, once you've started it, you get some information from it, and it will tell you what firmware version is in it, and it will tell you if there's an update available. So again, if someone in 5-10 years time has bought something and there is a signature that causes all AFDDs problem, you'll see an orange bar appear on the app, and you can update the firmware, and that might mean getting that new signature into the AFDD, so it knows that's a naturally occurring ARC from that new product, and it's off and running again for the next X amount of years. Oh, that's a really good feature. But you know, really it is, and people have asked us this, so I think, haven't they, Paul, that does that mean I've got to go around and update everyone's product? No, you haven't got to update everyone's product. You know, there's thousands out there. I've actually got 4 in my house which I don't have to update because I'm not getting that problem. So it's a feature we have in there that is possible to update. It doesn't mean to say you have to update, of course. And I think that's what's been a bit of a confusion on the market, certainly, isn't it, Paul?
Yeah, definitely. Absolutely right there, Paul. Well, thanks for that, Paul. That kind of brings us to the end. I think we're going to go to questions very shortly, but just to let you know that, there is a quite a vast amount of resource available from Hager. So please check out the link there, which gives you some advice on Amendment 2. It was updated lastly in May for the corrigendum. We also have the Academy online, so you can do online courses with us at your leisure from home. They're CPD accredited. We've currently got courses on AFDDs, SPDs, RCDs. We've got consumer unit design considerations. We've got an electric vehicle web learning course coming very soon. There's product courses to understand the part numbers and the huge range of equipment that we do, products that we do sell. So please check it out. So I think we'll hand back to Stephanie now, Paul.
Yep. If there's any
Great, thank
questions that come in.
Thank you very much. That's great. Thank you, Paul and Paul. So we'll now have time for a Q&A session. We have had some questions come through, so please do feel free to pop a question into the question box on the right-hand side. So we'll just get started on some questions. So the first question, which I actually think you've just answered, but I'll ask it again just for clarity. So it's great that your AFDD can be updated, but is it my responsibility to ensure updates are given to all installed devices?
Yeah, I think as I mentioned that, yeah. So no, it isn't their responsibility to go around and do all updates. Of course, it's not. Only if there's a report of a problem when the particular owner has bought this new product. We don't know what this is today, of course. We just put this in the product to try and future-proof the product. So no, it's not your responsibility to go around just because there's an update. You've got to go around and to revisit all the installed products. That clearly would not be practical.
Right, thank you very much. So another question that we've had come through. So any AFDDs for DC circuits now or in the future?
Not something that we've currently been looking at. Whether there is technology out there, Paul, would you be aware of any? I can see where this question's going. Solar PV, we get PV fires with loose MC4 connectors, etc. But no, I'm not aware of anything. That would probably be something that would have to monitor it from the inverter end, wouldn't it, or of the installation?
Certainly, this product is not designed for that. Of course, you couldn't fit one of these into a DC system. There's some MCBs you can work on DC, of course, but not these are not designed. If you remember the 0 point crossing, it likes to analyze the 0 point crossing and see the rise and the fall of the voltage to actually do its job. So they wouldn't work on a pure DC, no.
I know that when the regs changed, I think it was in Amendment 2, possibly, don't quote me on that, but there was requirements for inverters to monitor the installation of the cables, so who knows, maybe in the future, but it's not where we're at now. Thanks.
Thank you. So we've got, I think, a little bit more time for a couple more questions. So the next one, so should AFDDs be fitted to EV charge points?
That's a really good question, because I think when the regulation was written, the intention was for general purpose socket outlets, certainly it could be commando sockets up to that 32 amp sort of threshold. So with EV charging, we would probably say, yes, you would have to put AFDDs for mode 1 and mode 2 charging, because they do use general purpose socket outlets for mode 1 and 2 charging. But for mode 3 charging, where you've got wall boxes, is that a socket outlet, or is that a piece of electric vehicle connection unit, or a different term I think they use? So probably, whilst the reg is not that clear currently as it sits, probably I would say the majority of trade bodies out there would probably look towards a mode 3 wall box as being a sort of special connector and not a socket outlet, in which case it would fall outside of the remit of this regulation. That would certainly be my opinion anyway.
Yeah.
Great. Thanks, Paul. I think we'll go for one more and then we'll wrap it up because I'm conscious of time. But the final question, so are AFDDs bidirectional?
Oh, another good question. We're seeing lots of topics about bidirectionals these days, aren't we, with RCBOs? No, they're not actually. If you look at the terminal markings on an AFDD, you will see they're marked out and the incoming terminal at the bottom is marked in. So devices marked in and out are by definition not bidirectional. So we'll have to say, no, they're not bidirectional. They probably wouldn't be used or not necessarily be used, not requirement anyway, to kind of feed the input from an inverter anyway. We'd probably want more of an RCBO than an AFDD because there's no socket in that circuit there anyway, is there? So no, they're not bidirectional, and they probably don't need to be at the moment anyway, I guess, to be fair.
Thank you. Thanks, Paul. So I think we'll wrap it up there. Thank you both so much for your time, and thank you to everybody for joining. Just a reminder that CPD certificates will be emailed directly from the CPD, which can take up to 4 to 5 weeks. In the meantime, if you do have any inquiries, please do send them over to marketing@rexel.co.uk. Once again, thank you so much for joining us today, and we look forward to having you on future webinars.
Thanks very much.
Thanks.
Thank
Bye-bye.
you. Bye-bye.